Okay, I'm going to talk about the difference between total mass or charge or just stuff versus the density. So, for example, the mass density, the charge density, the probability density, really just the stuff density. Whatever stuff you care about, there's a density associated with it. And the difference is that this is a number and this is a function. Right? And they're related, actually. So the number, it'll be the integral of the function. So that is the total stuff. It'll be the integral of the stuff density times the area. And dimensions, so basically the stuff density is the stuff divided by the area. So for example, the density of water. It's 1 kilogram divided by a cubic meter, right? So it's the stuff you care about. It's 1 kilogram of water divided by in this case it's a volume, but really it's just a size, right? It's a size of a region, right? And so that's the reason why density is not stuff. Density is actually a ratio of stuff to size. Okay? So, and of course you can get the total water by density times volume or area, whatever size we have. The size times the density will give you the total. Okay? And so really density, really this is just the content of these double integrals. You multiply, if you have a bunch of rectangles, you just multiply delta A times the density at that point, and that'll give you the stuff at that point. For example, the mass in that square. And so now if you sum over the squares, that's just the same as doing an integral over the region. So that's just, you're summing rho dA. And that'll give you, again, the mass in the region. Okay? So another difference, not just function versus number, but another difference is the dimensions. Well, it'll always have the dimensions of, the density will always have stuff divided by area, or volume, or size, and the total will always have dimensions of the stuff. So, for example, mass over area, that's the density. That'll be kilograms per meter squared. And in the total case, it'll just be kilograms. It'll be mass. So if you just remember to label the density or the mass with the dimensions before solving your problem, you'll make less mistakes. So in physical problems, keeping track of what the dimensions are is one of the best ways to not make mistakes that I know of, at least. And yeah, I hope this helps. At least give you sanity checks.